Hello guys, for this video I will do a transfer function of this RLC circuit in MATLAB, and let's see how we calculate its transfer function. Then we'll use the transfer function in MATLAB to find its what you call step response of the graph. Then we'll find the information about the graph, its overshoot percentage, its rise time, fall time, settling time, and its peak value. So then let us start. I have a RLC circuit here, as you can see. It has the value L is 0.3 Henries. The resistance is 50 ohms and the capacitance is 15 microfarad. Then our output voltage is across the capacitor. Now input voltage is this side and we have a current flowing through it. Then I have my differential equation I calculated for the RLC circuit, as you can see here, with the output differential equation also. Then I used Laplace transforms to get the transfer function of the system. As you can see, that's Laplace transform for the input, and for the output Laplace transform. Then our transfer function is output over input, which gives us this equation here, which is our transfer function of the system. Then these are the values. So let's go to MATLAB then. I have my MATLAB open. I'll use live script. Then let's just uh, write the values for our components. Our inductor value, resistor value, and our capacitor value, C, which is 15. Then to write, then micro, you can say E minus 6. That gives us our capacitor value here. As you can see, that's our capacitor value. Then if you go back to the document here, our transfer function is 1 divided by L times CS squared plus CR times S plus 1. So let's go to MATLAB there. Then this is how we'll do. We'll have our transfer function has a numerator, which is just, you can make it like an array, 0, 0, and 1. This 0 represents, let's say, S squared. This 0 represents S, and this one is without any powers. Then our denominator will be, as I said, it's L times C, then R times C, then we have 1, which you can see why, because it's S squared, then S, then 1. That's why we have that. And let's just say multiplied by C. Then it calculates the value. If we run this part, it should give us the value. As you can see, it gives us the value. It's quite small, this value, so it doesn't show, but when we do the calculation it will show us those values. When we say we want a, let's say, represent transfer function TS. So to get the transfer function, just type TF. It's a built-in function that will give us the transfer function. Then you write the numerator and the denominator. Then if we run this, as you can see, it gives us the transfer function of the system here, right? Yeah. And from there, to plot this graph, we can just find, say, a step input of this system, just says the step, you just type in TS. Then if you just type in TS, just wait for that will give you the graph of the system or the step response of the system. As you can see, it gives us the step response of this transfer function. Then we can write, let's say we want a grid, just type in grid, it should be on. Then we also already labeled amplitude and time, but if you want to change the label, you can say while label. You can label that V in between two inverted commas voltage, and then X label is alright time. Then our title is also alright, step response. And then you can also on the grid, I believe you can change what kind of how do you want to represent it. Let's say with a star. You want to represent your graph with a star, you can do that. With a plus, you can do that also. So there are different ways how you can represent your graph, but in simplest terms, let's just keep it one line. Then we want to also find the information for the graph, so just type in step info. That, as you can see, it gives you the rise time, settling time, and other step responses. Then you just in this you just write the transfer function TS, and if you run this, as you can see, it gives us the following about the system, the response of the system. It has overshoot the peak time and the rise time. Which I think the transfer function is simple enough to do calculation. Even in MATLAB, you can calculate from differential equation to get the Laplace. You use differential equation in MATLAB to calculate the transfer function. But I prefer it's easier rather doing yourself than coding it in MATLAB. Then just code the information in MATLAB and plot those graphs, then you get these informations. Yeah, that's all. Thanks, Labs.